Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the first module of this course, that is the introduction module. And the idea behind this module is to give you a basic introduction to operating systems. So within the first module, we are on the last topic, that is the compute stack. And as we already know, the compute stack is a view of the computer system where we say that the computer is composed of a stack of multiple layers. And in this topic, we have seen almost all of the layers, that is hardware, operating system, programming libraries, user applications, right? So we have seen all these four layers. Now we are going to see the topmost layer of the compute stack, that is called the user interface. And this is the layer with which the user interacts. And it's a very important layer because this will finally determine the user experience and the interaction that the person who is using the computer will have, right? And in this video, we'll also look at the different types of user interfaces that are there in a computer system. So without further ado, let's get started. So let us now talk about user interface applications. But before I do that, let's quickly recall the user applications that we just studied in the previous video. So basically in the previous video, we said that a computer system has a lot of user applications, and this is the layer of software with which the user is most concerned with. You can say the sole purpose that the user is running the computer and interacting with it is these user applications. So basically the user is interested in launching some of these user applications and getting their work done. So this was about the user applications. And now let us talk about this user interface applications. So basically these two applications are the same, right? There is not much difference between these two applications. At the core, both of them are applications, but the only difference or the special thing about user interface applications is that they allow the user to launch these applications. And apart from launching this, they allow the user to interact with the overall system in general, right? So this was about the user interface applications. Now let's talk about the placement of this layer of software. So as you can see, the user interface applications are the topmost layer in the compute stack. And just like these user applications, they are written on the same interface, that is the programming interface, which is exposed by the programming libraries. And so as you can see, there is a thin layer of encapsulation over the user applications by these interface applications. So what is this trying to show? It is trying to show that these applications act as an intermediary between the user and these user applications. So since they allow the user to launch these applications and use them, so the kind of user interaction and the experience that the user will have highly depends on these interface applications, right? So when the user is using these applications, it is depending or interfacing them through these interface applications. So the user experience is highly determined by the kind of interface application that the user is using. And finally, the interface of these applications is called the user interface. This is the interface with which all the users of the computer system will interact, right? So this was about what the user interface applications are. So there are two types of user interface application. The first one is the graphical user interface. It's also known as GUI for short. And the second type of interface application is the command line interface. It's also known as CLI. So now what we will do, we will look at each of these types of application in more detail. So this is how the GUI looks like, and it is the most preferred way of interacting with the system. So almost all major operating systems provide a GUI, right? And the GUI is basically a visual way of interacting with the system, and it is composed of several visual components. So let us talk about these components. So basically when you boot up your system, the screen that you see, that is the GUI. And as you can see, this is the Windows operating system, and this screen is called the desktop, right? And on this desktop, there are several icons, and each icon is basically a logo that represents a user application. So users can click on this icon, double click on this icon, and when they do that, the user application will be launched. So this was the icon, and when the user application is launched, this kind of a rectangular screen is shown. So this is called the window. So the window is the region where we can interact with the user application. And on the window, there are several menus. So when you click on a menu, there is a drop down, where there are several options, and you can select these options to use the features that the user application provides. Apart from the menu, we have some buttons. So as you can see, there is this minimize button, maximize, close. So these buttons also help us to interact with the application. And finally, we have some scroll bars. So you can see this is the vertical scroll bar and this is the horizontal scroll bar. These scroll bars are basically used for navigation. So you see how the graphical user interface is composed of so many visual components. So we talked about the desktop, then we saw the icon. Here we have the window, then menu, buttons, and scroll bars. So this is how the graphical user interface looks like, and it has several visual components. So the next point is that in order to use a graphical user interface, we need a pointing device like a mouse or a touchpad. So on desktops, we generally use the mouse, and on laptop, we have the touchpad. So basically, actually, the pointing device is what makes the GUI very easy to use. So there are several things that we can do with a pointing device. The first is the obvious, that we can point to different locations. So when we want to click on a button or any particular area, for example, it could be an icon, right? So it helps the user to point to a specific location. So pointing is a very important feature. Then apart from pointing, we can also select. So selection is basically selecting an area or some objects on the screen. And apart from selection, we have scrolling. So on newer mouses, we have the scroll button, which helps the user to scroll up and down on the window. So these are the different actions that a pointing device provides, and all of these makes the using the GUI very easy. So the next point is that the GUI is very user friendly and easy to use. So just a slide ago, we discussed that GUI has several visual components. For example, we have the icon, then we have the window, there is menu, there are buttons and scroll bars, and several more visual components. And if you combine all these visual components along with the pointing device, then this makes the user interaction for the user very easy. That is why for most of the operating systems, the GUI is provided as the default option. And when you compare this GUI with the CLI, you will realize how easy the GUI is. So this is the point, that GUI is more commonly used as it has a friendlier user interface. So we just saw the upside of using the GUI, that is, it is very easy to use and has a much friendly interface. But there is a downside also, that the GUI does not expose all the features of the computer system. So some of the advanced features that are not exposed. For example, features or operations like changing system config files or doing some sensitive operation, all of these you cannot do via the GUI. For that, you have to resort to the command line interface that we are going to see next. So this is the downside of the GUI, that it does not provide that level of control that a command line interface provides, because some of the advanced features are not exposed. So these are some of the example GUIs for major operating systems. So here we have the Windows, then we have Mac OS, and finally this is for Ubuntu. So as you can see, all of these GUI appear very similar. There is a desktop screen, there are some icons, right? There is a bar. So the point is, most of these GUIs will provide all the common visual components that are characteristic of a GUI, but still these GUIs will be unique in their own way. Although the features that they provide remain the same, but the way in which they will provide is still unique to these operating systems. So this is how the different operating systems GUI look like, right? So now let us look at how the GUI can vary even in the same operating system. So in the previous slide, we saw that different operating systems will have different GUI, but within the same OS also, you can have multiple GUI options. So for example, here you can see the in the Linux OS, you have two different GUI options to choose from. The first one is called the KDE and the second one is called the GNOME GUI. So although both are GUI and the overall user interaction kind of remains similar, there will be the same visual components, but the overall theme and appearance is different, and you can choose one that suits your preferences. So the next point is that as the operating system evolves or goes through multiple revisions, so not only the internal kernel code changes, but also the GUI also changes or evolves. So as you can see here, Windows has gone through several iterations, and with each iteration the overall GUI has improved. So basically the GUI, you can think of it as the packaging of the OS. So internally, as the OS is improving and changing, so does the packaging of the OS itself, right? And you can compare two different versions of Windows. So this is the Windows XP, which was around 2001, and this was Windows 11, which was released in 2021. So around 20 years of gap, and you can see how the overall UI has significantly improved in the Windows 11. The icons, the bars. So Windows 11 has a much more advanced and premium look as compared with the Windows XP. So the previous slide might actually confuse you, and you might think that the user interface application is also part of the OS. Let me clearly call it out. It is not. So we should not confuse these two different pieces of software. They are totally different. So user interface application and operating system are running at two different layers. These are two different pieces of software. Although this confusion can arise because operating system vendors ship the GUI along with the operating system, and the GUI is like the face of the operating system. The only way to interact with the operating system is the interface application. So this confusion can arise, but let me clearly call it out. The user interface application is just like any other user application running in the user space that just helps you to interact with the system. It is not part of the operating system. So now that we have looked at the graphical user interface, let us now look at the other option that we have when we talk about user interface applications, that is the command line interface, right? So this is how the command line interface or the CLI looks like. So basically the CLI is based on a command interpreter. So this is the command interpreter. It has a terminal like this, and here we have the command prompt. So the command prompt is where the user is supposed to give their input via the keyboard. And the way the command interpreter works is that the user will type in some command for whatever task that they want to do. They have to type a command, right? So this is the basic way of interaction with the CLI. For everything that you want to do, you will have to type the appropriate command. And what the CLI will do, it will basically parse those commands and figure out what the user is requesting it to do. And then it will execute that command for the user. And after that command has been executed, the command interpreter will wait for the next command from the user. And this keeps on happening in a loop. You give in a command, the interpreter will execute that for you, and then it will wait for next command, and the user will then give the next command. So this is how this keeps on happening in an iteration. So this is the basic fundamental idea behind the command line interface. It's a text-based, command-based interface, and as you can see, there are no visual components. If you compare with this with the graphical user interface, there were several visual components, and none of them are present here. It's a text-based interface. You give in the command, and the interpreter will execute that for you. So now let us talk about the command. Basically, the CLI is a command-based interface, right? And for any operation that you want to do, you will have to give in the appropriate command. And what are these commands? These commands are basically programs or executable files that will be executed when you give in the command. And with the command, you have to give some appropriate options. So these options are basically used to control the behavior of the command, right? So as you can see, there is a directory command and a /o option has been given. So this command is basically used to list the contents of any directory, right? So this was about the options. These options also act as arguments. So you can specify some arguments to the command as well. So now if you see to use the command line interface, you need to have a proper knowledge of the command and the options that have to be provided. So this requires some bit of learning and is somewhat difficult if you compare this with the graphical user interface. There, for any application, there was a logo or icon. All you had to do was double click that icon. And for doing operations on that application, there were well-defined menus. When you click that menu, there was a drop down, and you can all you had to do was select some option from that menu. So you see, using the graphical user interface was quite easy in that sense, launching programs or doing any operations. But when it comes to the command line interface, you have to know the command for any operation that you want to do. And apart from that, you also have to have the knowledge of the appropriate arguments. So the next feature about the CLI is that it allows you to automate repetitive tasks. And the concept that we use is called scripting. So basically, if there are any set of tasks that you have to do frequently, that is, you have a repetitive task, Then what you can do in the CLI, since for every operation that you want to perform, there is a command, right? And if there are a set of such commands that you want to execute again and again, then you can write all of these commands into a script file. And now whenever you have to do that repetitive task, instead of typing those commands again on the shell or the interpreter, you can just run that script. So this is how the CLI interface allows you to automate that task. So when you run that script, basically it's kind of a interpreted language. So it's kind of a programming language which is not compiled, it's interpreted line by line. So the command line interface will go over the commands that you have defined in that script and execute all of them. So now basically your repetitive task has been automated. So this is one feature which is not present in the GUI. If there are a set of operations that you have to do again and again, then GUI does not offer a simple way to automate those tasks. Whereas in the CLI, you can just put all those commands in a script and execute them. The next point about the CLI is that it exposes all the features of the system. So we saw that the drawback of the GUI was that although it was very user friendly and the interaction was quite easy, but the downside of the GUI was it does not expose all the features of the system. So there are certain advanced features that are only exposed by the CLI, such as changing some configuration files, system configuration files, which control the behavior of the system. So many operations, many sensitive operations like these are not exposed by the GUI, right? So these are reserved for the CLI, and advanced users can use this to control the behavior of the system. So this is the upside of the CLI, that although it might not be easy to use, but it exposes all the features of the system. And that is why advanced users prefer the CLI, because this gives them more control over the system as a user. The final point about the CLI is that it is less user friendly and difficult to use, which is quite obvious, right? So first of all, as you can see, if you compare this with the GUI, there are no visual components. There is no icons, menu, window, scroll bars, nothing is there, right? You cannot even use the pointing device. So it's a basically text-based interface where you have to solely rely on the keyboard. This is the first point. And the second point is that for any task that you want to do, you will have to give the command. And the command, you have to know the command, you have to know the options, what kind of arguments you have to provide. So basically, there is a learning curve that is involved with using the CLI. So all of these makes the CLI less user friendly. And overall, the appearance wise, if you compare the appearance of the GUI with the CLI, it is very plain, right? So all of this makes the CLI very difficult to use. Not very difficult to use, but still it is lot difficult than the GUI, and it's less user friendly compared to it, right? So it's often preferred by advanced users only who want more control over the system. Normal users generally go for the GUI. So here we have some example command line interfaces from popular operating systems. So the first one is from Windows, and the second one is from Ubuntu, which is a popular Unix based operating system. So as you can see, the command interpreters in both the operating systems look very similar. So there is a command prompt which basically displays the name of the user or the machine, and you have the command and the options. So the command interpreter is basically very simple, and in all operating systems, the command line interface will look almost the same, right? Having said that, we have this similarity, that is the appearance is similar, but the commands that you will use to do the operations will be different across different operating systems. So let's take an example, that is to list the contents of a directory. So in Windows, you see we use the directory command, and in Ubuntu we use the ls command. Even the options are different. So this is the difference between command line interfaces across the operating system. So for doing the same operation, you will be using different commands, right? So this was about how different command line interfaces look like and work in different operating systems. So the next point is that within the same operating system, you can have different CLI applications to choose from, right? So just a few slides back, we were discussing the different GUI options that exist on the Linux operating system. So two popular options were the GNOME project and the KDE. So in a similar way, when it comes to command line interface, there are several command interpreters that have evolved over time. So on the Unix based operating systems, the command line interface has been the dominant way of interacting with the system. So different shells have evolved over time. So the Bourne shell was the original one, and different derivatives were written over this. So all of these interpreters provide some unique features which you can use as a user, whichever suits your needs, right? So the point is that within the same operating system, you can have different CLI options to choose from. So now we have seen both the graphical user interface and the command line interface. So now that you understand how each of these user interface application works, so you can see that a user interface application basically gives you a unique view of the same operating system. So let's say you are on the Windows operating system, and this is how the Windows GUI looks like, and this is how the CLI looks like. So depending on which user interface that you choose, you will have a different user experience. The interaction is altogether different even on the same operating system. So the point that I'm trying to convey is that a user interface basically defines a unique view of the same operating system. And if an operating system provides multiple choices for user interface application, then depending on the user interface application that the user chooses, they will have a unique experience depending on whichever UI they choose. So the point that we just discussed, that a given user interface application provides the user with a unique view of the same operating system. So that point I want to convey through this compute stack as well. So this is the compute stack, and let us modify this compute stack a bit. Let us assume that the given computer system has a Windows operating system installed. And as we know that Windows has two different choices when it comes to the user interface. The first one is the Windows GUI, and the second one is the command prompt. So as a user, when they are using this system, they will have two different views of the same operating system, that is the Windows operating system, when they use the GUI versus when they use the command line interface, right? So this is how you can visualize this concept from the compute stack. So now let us make this idea even more interesting and see how does the situation look like when we have different operating systems installed on the same computer. So now let's look at a very interesting example. Let's say you have a computer hardware, and on that computer you have two different operating systems installed. So basically the point is you can dual boot the system. The first one is the Windows OS and the second one is the Linux OS, right? So the user can now choose to use any operating system that they prefer. So the first point about this diagram, this compute stack, is that the same hardware has now two different views since there are two different operating systems. So if you see the operating systems interface, that is the system call interface, it is very unique for each OS. So now for the same computer hardware, there are two different views depending on the operating system that the user chooses to use. Now in the previous slide we said that for the same operating system, depending on the user interface application that you choose, there also your user journey or user interaction will be quite different. So now you combine these two facts. First of all, that multiple operating system can provide different views of the same hardware, right? And then on top of this, multiple user interface options will provide different views of the same operating system. So now as a user, you can see how many different views you have, how many different user interactions or user journey you can have while using the same computer system. And the example in Linux is even more interesting, because not only there are two different types of interfaces, that is command line and graphical on Linux operating system, even within a single type of interface, that is command line interface, you have a variety of shells that are available. So in the previous slide, we saw roughly 7 to 8 different shells that you can use when using the Linux operating system. And when it comes to the graphical user interface, there also you have two different popular options. One is the KDE and the other one is the GNOME. So all of these are listed here. So these are the CLI options, some of the CLI options that you can use when you're on the Linux operating system. And these are the GUI options. So you can see how the compute stack now looks like. On a given hardware, you can have multiple operating systems. So here only there is a bifurcation of user journey depending on whether you are on Windows or whether you are on Linux. And on top of the same operating system, you can have two types of interfaces, either graphical or command line. And again, even within the same type of interface, there are several options, like depending, you can use different types of shells or your choice of graphical user interface. So now as a user, the point is you can see for the same piece of computer hardware, you can have different user journeys while using the same system. And this is what makes this compute stack so interesting. So the next point is an important one. So when we talk about the user interface or the user experience of using the system, it is not just defined by the software. So till now we have talking about either graphical user interface or the command line interface. So these are two pieces of software, two different types of software. But the point is that it's not just the software that determines the user interface, the hardware also plays a very major role. So in this slide, you can see there are three different types of computing environments. And let's discuss how the hardware plays an important role when it comes to determining how the user interface will be. So the first class is the desktop or laptop. So these are the traditional computing environments. And here you can see the major devices that are used for user interaction are the keyboard and the mouse or touchpad. So using mouse or the touchpad, the user will be giving the pointing location, and then there is the keyboard for textual input. Even there is a distinction between desktop and laptop. Depending whether you're using a mouse or a touchpad, your user interface will vary. So this is how the hardware is playing an important role in determining how the user interface is. And now let's talk about the modern computing environments, that is smartphone and tablet. First of all, these are portable, right? The device itself is portable. That itself really changes the user interface, user experience. And now we don't have any external devices that are required to interact with the system. We don't have keyboards or mouse. The keyboard is, so basically we have a touch screen in these devices. So there is a large area, and we can use our fingers to interact with the system. So the keyboard is present in the screen itself, and for pointing you can use your fingers. There are some stylus also used in some devices, but you can see how the interface of these modern computing environments, that is the smartphone and tablet, is altogether different from the traditional stationary computing environments like desktop and laptop. And finally, let's talk about the embedded systems. So basically all the electronic appliances that you see in your home, so they also have a very minimal computer installed. So it could be a washing machine, it could be a fridge, it could be a microwave. So they do have a very specific special purpose chip that is installed in these systems that control the overall function of the system. So it's still a computing environment. It's not like a general purpose computer that we see, that is desktop, laptop or smartphone. It's a very special purpose chip, but it's still a computing environment, right? And even a minimal version of OS is installed in these systems. So these are called embedded systems. And if you see, the user interaction in these type of systems is very minimal. There is some buttons, there are some display screens, there would be some knobs or some sliders. So as you can see, they do have a user interface, but it is very minimal. Why? Because the hardware that is involved in interaction does not require much of interaction from the user or intervention from the user. So the hardware that is involved in the user interaction is very minimal. So you can see how the hardware is playing a major role in determining how the user interface of the computing environment will be, right? So till now we have been talking about graphical user interface or the command line interface as two different ways of interfacing with the system when the computing environment is a traditional one like the laptop or the desktop. So now I just want to touch upon the user interface that exists in modern computing environments like smartphones or tablets. So here you can see the touchscreen interface. So basically here we have three different mobile devices. First is an Android phone, the second one is an Apple phone, and the final one is a OnePlus. So these three different phones have different OS first of all, and even the touchscreen interface application is different. So you can just check out the different applications and you'll see different logos for different application in these three phones. You can check out Google Chrome, the calling application, and the messaging app. Each of them has this, and even the logo is different, right? So this is how even in the touchscreen space there is a wide variety, lot of options when it comes to depending on the smartphone that you're using. So guys, this was it for this video. In this video, we talked about what is a user interface application. We discussed the different ways. There is a graphical user interface, command line interface. So this was for the traditional computing environment. And then for the mobile and smartphones, we have touch screen. And we also saw how the compute stack is defined by the user interface application. Basically, within the same computer, we can have multiple operating systems. And on the same operating system, we can have multiple user interface application, and all of these basically give different views of the same system, right? So this was it for this video. Thank you very much for watching, and I'll see you in the next video. Thank you.